Hello, welcome back. It's been a long vacation since we're just coming off of the Christmas vacation. Hope you had a good time. Today our homework is going to involve something that we've kind of done before, but it's going to be a little bit of a review as well because, we've had 2 weeks of vacation. Okay, so today's lesson is 3rd grade, Module 3, Lesson 12. And our objective is that we are going to apply the distributive property and the fact 9 equals 10 take away 1 as a strategy to multiply. Okay, before we can do that, I would like to remind you or kind of show you another way to do some subtraction problems. Okay, so the first graders have done this before, but I need to catch you up on that. Okay, so if we have, whoops, apparently I didn't pick the pencil. There we go. Let's say that we have the number 20 take away 2, and we want to find out what it is. If we break it apart and we take out a 10, so let's take out a 10. How many 10s are left if this is my number bond? 10 plus what gives me 20? Another 10. Okay, now this is when we can do the subtraction. So if I take 2 out of this 10, what do I have? Well, 10, 8, 9, or 9, 8. So this is now 8. So then we add this part. 10 and 8 is 18. Okay? A little bit different. Let's try a different one. Let's do this one. Okay? Let's do 30. Take away 3. Okay? Make your number bond. Take your 10 out. 10 plus what gives me 30? 10 plus 20, right? Okay, now we do our subtracting. What's 10 take away 3? That would be 7. See how I just mark it down here? Now we have a 20 and a 7. 20 and a 7 is 27. There's my answer. Let's do one more, just so you can be good at it. Okay, let's do 50. Let's do 50, take away 5. Well, you may already be able to do that in your head, but I want you to do it this way. So make your number bond, take out your 10. Now 10 plus what gives me 50? 40, right? Okay, now do your subtraction with your 10. 10 take away 5 is a 5. 40 and a 5 is 45. That's right. Okay. Just so that you can remember how to do that. Now, let's work on our application problem. Make sure it selected the pen. A scientist fills 5 test tubes with 9 millimeters of fresh water in each. She fills another 3 test tubes with 9 millimeters of salt water in each. How many millimeters of water does she use in all? Is it asking about fresh water and salt water, or doesn't matter, just water, right? Fresh water is water, salt water is water. It's both together. But it tells us that we need to do something. It's not letting us have a choice this time. We have to actually do what it says. It says use the break apart and the distributive strategy to solve. Okay, well then we will do that. First, let's do a tape diagram. She says she fills 5 test tubes with 9 millimeters. So I'm going to make a tape diagram. And I'm going to put a test tube here. 1, 2, 3, 4, 5. And each one there's 9 millimeters. Right? So I'm going to label this 1 test tube. Kind of hard to write little. Okay. And this right here is going to be my total milliliters of water. Okay, make sure you label it. Now, so we're up to here. A scientist fills 5 test tubes with 9 millimeters of fresh water. Right there. So here's fresh. Fresh. There we go. Now let's do the other one. She fills 3 test tubes with 9 millimeters of salt water. So let's do 3. 1, 2, make it just a tad bit longer, Each one had 9 millimeters, but this time from here over, this is the salt water. So from here to here is fresh water, from here to here is salt water. Now, how many millimeters of water does she use in all? Okay, so how many groups of 8 or how many groups of 9 do I have? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. So 8 groups of 9. Now it wants us to use the break apart and the distributive property. Okay, so what was the 8? Well, it was 5 and 3. So here's our break apart right here. We're rewriting the 8 to make it like this, right? Okay, now we're going to use the distributive property. We're going to do 5 times 9 plus 3 times 9. But I'm going to do it 5 times 9, so they can each be multiplied by 9. But I'm going to put in parentheses just so that I can see it better. 3 times 9. Now why did I do that? Because this is the break apart. I broke 8 into parts. The fresh and the salt water, I broke them apart. Instead of just saying 8. So another way to write 8 is 5 plus 3. Distributive strategy is when I multiply it by each one. Okay. Now, 5 times 9. 5, 10, 15, 20, 25, 30, 35, 25, this is great, 40, 45, 45, right? Can you see my fingers? I don't know if you can see my fingers, but when you get to 9, you get 45. All right? So 5 times 9 is 45. Plus, well, what is 3 times 9? Count if you need to count. 3, 6, 9, 12, 15, 18, 21, 24, 27. 27. Now we add it up. I can't really add it up like that. So I'm going to make something, let's see, I'm going to make this one easier. What would it take to make that one be a 10? Well, if I take out a 3 from here, take 3 out, this would be a 42, right? So now I can add it to here. Here's my 10. So what's my 10? Now my 10 is 42 plus 30. Oh, that's easy. That is, our ones are the same. We add 4 and a 3, and that is 7. 72 milliliters of water. Okay? Now, excuse me. We're going to use a similar problem, okay? So this time, okay, excuse me. Oh, goodness. Oops. I want that one. No. Okay. Let me find my pointer so it doesn't keep putting dots everywhere. Current slide. Okay. I just went one slide too many. Okay, so let's use our pencil. Now, last time we did 8 times 9. Okay, so if we did 8 times 9 equals 72. Okay, so we had 8 times 9. Let's use the commutative property. We said that it was 72. If we use a commutative property, what does commutative property mean? Commutative property means we can flip-flop it, right? Okay, so 8 times 9, what would it be? 9 times 8, right? This is 8 groups of 9. This is 9 groups of 8. We remember from our arrays that when you have commutative properties, we can just flip-flop them, right? We can just turn the array 90 degrees or just turn it sideways and it's the same. The number of dots don't change. Okay. Now, this time it said that we had to use the 9 equals 10 take away 1. right? We have to find out how to multiply using this fact. This is very easy fact. I know you can do that in your head. Okay, so here's my 9 times 8. Let's solve it using this. But first I want to ask you, which is easier to solve, 9 times 8 or 10 times 8? Which is easier? Well, this one we already know because we just did it. But we know that anything times a 10 has a 0 at the end, right? So this is just 80. This is really easy to solve. This one you have to memorize or work through it. Okay, so let's use this one. So how many 8s does it have? It has 10 8s. So let's make a tape diagram with 10 8s. 2, 4, 6, 7, 8, 9, 10. Oops. I'm going to just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 8s. Okay. So here's this tape diagram. What if I needed to make this tape diagram? What would you do to this one in order to make this one? Now I don't want this tape diagram anymore. I want the 9 take away 8, or 9 times 8. What would you do to it? Well, you might erase one or just mark one off, right? Just take one away. Now I have a 9 times 8 tape diagram, don't I? I have 9 8s. 1, 2, 3, 4, 5, 6, 7, 8, right? I have 9 8s. Before I had 10 8s. Now I have 9 8s. Okay. So if we were to write this as a number sentence, what we just did, okay? All we did was we made a tape diagram, we made 10 8s, and we took away an 8. So let's write that out in the math way. So this is what we were looking for. And first, we did 10 times 8, right? We did 10 8s. Whoops. We did 10 8s. And then we took away how many 8s? I only took away 1 8. 1 8. Right? Okay, so let's solve this. 10 8s is 80. We're going to take away 1 8. 1 times 8 is 8. I have to break this into the tens. So this would be a 70. This would be a 10. I take away, do my subtraction right here. 10 take away 8 is a 2. 70 and a 2 equals 72. Do you see how this right here is what we did at the very beginning? Yeah. That's the reason why I wanted to remind you. Okay. Now, so we had that last number problem. Now, what if I write this? This is a true statement. This was the break apart rule, right? I just broke this apart. But it would work if we did it. If we solved it, it would still work, right? This is what we did first. Well, sort of. This is almost what we did. But is it what we just did? If I remember it, I did a subtraction. I took away an 8. This isn't going to be, we can't use this for that last sentence, can we? So the way we wrote 9, this isn't the right way because we took, remember we had our tape diagram and we took one away from it, right? This is adding. It's not what we did. So let's rewrite it to be what we did. Let's rewrite it. Now what did we do? How many did we have? How many 8s did we have first? We had 10 and then we took one away. And they were all 8s. So I can say that they were all 8s. So instead of writing a 5 plus 4 as a 9, another way to write it is 10 take away 1. Just because it's an addition or subtraction problem doesn't mean that it's right or wrong unless you're doing something specific like what we did here. 10 take away 1, that's 9. It's just another way of writing 9. How many things, what did we have here in each one of those boxes? They were all 8s. We were counting up 8s, so we multiplied by 8. Okay, now, this is where I'm going to leave you today. And make sure that you write your lesson, your module on your paper with your name so you can get your 10 free points. Good luck with your homework. See you soon.